Hi there, everybody. Welcome back to my channel. Today we're going to be working on a topic called the factors and multiples. This is the fourth video in my series known as the Foundations of Mathematics, where we're explaining the most basic fundamental topics important for students going into pre-algebra or algebra courses. Okay, let's begin. So what is a factor and a multiple? Let's start with factors. So let's say we have any given number. Let's say we start with 12. Okay, what a factor is a factor of 12 is any number or any pair of numbers that multiplies together to give us 12. For example, 2 times 6 gives us 12. So the numbers 2 and 6 are both factors of 12. 1 times 12 also gives us 12. So the numbers 1 and 12 are also factors. There's one more set of factors for the number 12. 3 times 4 gives us 12. So 3 and 4 are also factors of 12. I should make note that for factors, when we say two numbers that multiply together, we are talking about positive and whole numbers. So we don't have to worry about negative numbers. We don't have to worry about decimals, fractions, any of that. But we're talking about positive integers or whole numbers, and those are the factors for a number. Okay? So let's say 1, 2, 3, 4, 6, and 12. That is the set of all of the factors of 12. Okay, so now we know what a factor is. Let's go over what a multiple is. A multiple, instead of breaking 12 into its pieces, a multiple of 12 is 12 times any whole number, so 1, 2, 3, 4, and so on. Whatever the result is, that's a multiple of 12. So 12, 24, 36, 48, and so on. Those are all the multiples of 12. It's called a multiple because you're multiplying 12 by the integers, by a whole number, 1, 2, 3, and so on. Okay? So those are kind of a basic introduction to factors and multiples. Okay, there's another kind of concept that I would like us to talk about within this kind of idea of factors and multiples called prime and composite numbers. And prime and composite. Okay, so let's start with prime. Prime numbers are any number. Prime numbers are any number, any whole, we'll say number. That means any number 0 or greater than 1, or any integer greater than 1, greater than or equal to 1. Any whole number that has only two factors, namely 1 and itself. For example, the number 3. The only set of two numbers that multiply together to be 3 is 1 times 3. Right? Another example is 7. Right? 7. The only numbers that multiply together to give you 7 are 1 times 7. Okay? So any number where the factors of that number, right, are only 1 and itself, that's a prime number. Any other whole number where you have more than two factors or just one factor, we call those composite. Okay, so for example, an example would be the number 12, like we said. That has many factors. It had 6 factors up here, right? So that would be composite. Or another example is 4, because we have 1 times 4 or 2 times 2. So that gives us a total of 3 factors. That's 3 factors. That means we're composite, not prime. Okay? So that's the distinction between prime and composite. And these kind of flow out of what we mean by factor. Okay, so these are the definitions for today's video, but now let's actually get into the meat of the video, which is going to be describing how to prime factorize numbers and then how to find the greatest common factor and least common multiple. So let's start with prime factorization. Okay, what is prime factorization? This is a very useful concept that you will see in lots of different branches of mathematics as you move up into higher education. So prime factorization. Let's say we start with a number. We'll start with 12, okay? Basically, you start with any number, okay, and you're trying to break it down into its prime components. What I mean by that is, let's pick any two numbers that multiply together to be 12, any set of factors of 12. We'll say 2 and 6. Okay, so 6 and 2, we know that 2 is a prime number. 2, the only thing you can further break down 2 into is 1 and 2, right? So that's kind of would just be an endless loop of 1 and 2 if we continued, right? So that's not going to be super helpful. So we're just going to leave it at 2 because this is a prime number. We're going to circle it. So that's the end of our prime factorization. So that's a 2. The kind of diagram I'm showing you now is a prime factorization tree, right, or a factor tree, and it kind of leads you to demonstrate what a prime factorization is. Okay? So once we go to 2 and 6, we circle 2. 6 we can break down further because 6 is composite. Well, what numbers multiply to be 6? Well, 2 and 3 multiply to be 6. 2 times 3 is 6. But 2 and 3 are both prime. So that's the end of our prime factorization tree. So what does this mean? Okay, what this means is 1, 2, 2 2s, and a 3. So 2 times 2 times 3 equals 12. The resulting ends, or the ends of the branches of this prime factorization tree, give us the prime factorization. That's what we call the prime factorization of the number 12. So the way that we can describe the number 12 is by saying 2 squared times 3, right? Because we have 2 2s and 1 3. That's the prime factorization of 12. Okay, let's do another example really quickly. Let's say instead of 12, we want to work with the number, we'll go with 60. Okay, well, what does 60 break into? Well, 60 breaks into 2 and 30. Okay, well, what does 30 break into? 30 breaks into 3 and 10. Okay, what does 10 break into? 10 breaks into 2 and 5. Okay, can we break either of these numbers down anymore? Well, 2 is a prime number, 3 is a prime number, 2 is a prime number, and is 5 a prime number? It is, right? Because no two numbers besides just 1 and 5 multiply to give us 5. So 5 is prime. So this would be the prime factorization of 60. 2 times 3 times 2 times 5. 2 times 3 times 2 times 5. Or 2 times 2 times 3 times 5, or 2 squared times 3 times 5. So this would be the prime factorization of 60. If a question asks you to find the prime factorization of the number, this is how you would do it. You would write this prime factorization tree, work your way all the way down until you are left with just the prime numbers that multiply to be the value, and that's our answer. Okay? That's a prime factorization tree. Okay. Now, the next and the final two concepts that we want to teach today are the greatest common factor and least common multiple concepts. These show up a lot in pre-algebra and are very important, okay? So greatest common factor. Let's see, greatest common factor. Okay, so what is a greatest common factor? A greatest common factor is when we have two numbers, for example, the numbers 12 and 30. Okay, two numbers. The greatest common factor is basically the largest number that is a factor of both 12 and 30. So let's write down the factorization of 12 really quickly. We said earlier that it was 1, 2, 3, 4, 6, and 12. These are all the factors of 12. Okay, and we could do a prime factorization to tree, or we could think about it to find the prime factors of 30. But instead, I'll just write them out for ease. 30 has 1, 2, 3, 5, 6, 10, 15, and 30. So if we're looking for the greatest common factor, what is the largest number that is a part of both groups? Well, they both include 1, but that's not the largest. They both include 2. They both include 3. They don't both include 5, but they include 6. They both include 6. And does 12 includes 12, obviously, but 30 doesn't include 12. So 6 is going to be the largest number that is a factor of both 12 and 30. and therefore we call the GCF, the greatest common factor of 12 and 30, is 6. So that would be how we answer a question like this. But let's say the numbers we were given were a little bit more difficult, right? And you weren't able to just find all of the factors very easily, right? Just like that, right? A faster and more efficient way to do this is to prime factorize both numbers. So what do I mean by that? Let's go back and do the prime factorization of 12. We said it was 2 times 2 times 3. And if we were to do the prime factorization of 30, what we would be left with is 2 times 3 times 5. Okay, if we were to do a prime factorization tree. So all we did was we did a prime factorization tree to figure out the prime factorizations of 12 and of 30. And now what we do is we see what's in common. Okay, well, what's in common? Well, a 2 is in common. They both have a 2 in common. And they both also have a 3 in common, right? The difference lies in this 12 has an extra 2 and this 30 has an extra 5. But the common things are what we care about, right? It's called a greatest common factor. So in order to find our greatest common factor, we're just going to multiply all the common pieces together, all the common prime numbers, 2 times 3. So that's what was in common between 12 and 30, right? So 2 times 3 is just going to give us our greatest common factor of 6. Okay, so now let's go into what's the least common multiple, this concept of a least common multiple. Okay. So we've done the factor side, the greatest common factor. This is its kind of counterpart with multiples, the least common multiple. So remember, what a multiple is just all of the numbers that when you take some base number, like 12, and multiply it by the whole numbers, that sequence of numbers that you get, that's a least common multiple. For example, 12, 24, 36, 48, and so on. But a least common multiple is when you take two numbers, say 12 and 30 again, okay, what is the least multiple of both of the values that is common between the two? So, for example, in the list, 12, 24, 36, 48, 60, 30, its list is 30, 60, 90, 120, 150. Those are its multiples. So what is the lowest number that is common in both of these sequences? Well, we can see it immediately. The lowest number is 60, right? Because this one's only going to keep going up. This one only keeps going up, and there's nothing below 60 that works. So this is what we call the least common multiple, okay? Now, if we want to do this systematically, instead of having to list all of the multiples or for large numbers, right, as you'll see in an example later, there is another way to do this, also having to do with this idea of prime factorization. So what we're going to do, we're once again going to do a factor tree. We're going to find the prime factorization of these numbers. So from the previous question, 12 is 2 times 3. 30 is 2 times 3 times 5. Okay, so now once again, we're going to look for the things that are in common between these two. Well, what's in common? Well, this 2 and this 3, and this 2 and this 3. We'll actually double underline the 3 so we can see how it's common, okay? So those are the common factors, and the other things are the uncommon factors between the two, okay? Now, the technique to find the least common multiple between these two, we're going to multiply the common numbers, right? Just like we did earlier, 2 times 3, right? So we're going to multiply the common numbers, and then we're going to multiply every other uncommon number as well. So we're going to multiply 2 times 3, and then we're going to multiply by 2, and then we're going to multiply by 5. Okay, and what does this give us? 2 times 3 is 6, times 2 is 12, times 5 times 12 is 60. As we expected, that gives us a total answer of 60 as the least common multiple. So just to reiterate what we just did, we took the common values, right, and between the two numbers, okay, and we multiplied them one time. So instead of multiplying 2 times 2, right, we just write 1, 2. And instead of doing 3 times 3, we just write 1, 3. Okay, but then we also multiply by the additional uncommon values, the 2 and the 5. And when we do that, we get a total of 60. Okay, so let's do a practice question together, shall we? Okay, Factors and multiples. Here's our first question. Find the greatest common factor, the GCF, of 30 and 60, or 36 and 60. Okay, pause the video if you want to try both of these questions, and we're going to go over them. So let's go over them. 36 and 60, GCF. So how are we going to do it? We're going to prime factorize 36 and 60. So 36 prime factorize, we're going to do a tree. 36 is 2 and 18. 2 is a prime number, so we circle it. 18 can break into 3 and 6. 3 is a prime number. 6 can break into 2 and 3. Those are all prime numbers. So 36 is just 2 times 2 times 3 times 3. Okay, now let's do that same thing for 60. 60, prime factorize it. We get 6 and 10. Okay, 6 breaks into 2 and 3. Those are both prime. Let's go to the other branch. 10 breaks into 2 and 5. Those are both prime. So 60's prime factorization is 2 times 2 times 3 times 5. Okay, we have their prime factorizations. How do we find the greatest common factor? We look at all the common prime factors between 36 and 60. They both share 1, 2 in common. They both share a second 2 in common. They each have a second 2. They also both share a 3 in common. So those are all in common. And then that 3 and the 5, those disagree. So we see that they share a 2. They share a 2, another 2, and a 3. So we multiply all those together, and what do we get? We get 2 times 2 is 4, times 3 is 12. So the GCF of 36 and 60 is 12. That is the largest factor. That is a factor of both 36 and 60. Now let's find the least common multiple. Once again, for 6 and 10. Okay, so the least common multiple here, we're going to have to prime factorize 6 and 10. What we need to do is, well, what's 6 broken into its prime factors? Well, 2 and 3 multiplied to be 6. Both of those are prime, so 6 is just 2 times 3. That's its prime factorization. Okay, what is 10 prime factorized? 10 is just 2 times 5. Both are prime factors, so 2 times 5 is its prime factorization. What is shared in common between these two? Well, there's a 2 shared in common. So we multiply 1, 2 by the things that are uncommon between the two. 3 is uncommon, 5 is uncommon. It's only found in one of them. So we multiply it times 3, and then we multiply times 5. Now we find this value to be 30. So 30 is the least common multiple of the numbers 6 and 10. Okay, so that concludes our discussion of factors and multiples. I hope you found this video helpful. Comment if you have any questions or want me to go over certain topics, and I'll see you in the next video.